Hello, welcome to Space Oddities. We're back. Thank you so much for joining us. And how are we today, panel?
We're fine, thank you very much.
Good.
Nice to be back.
Ready to go again? And on a
Raring.
packed program tonight. We've got a lot of lovely stuff to bring you tonight, which we hope you're going to enjoy. As I said, thank you so much for being here. And we're going to get straight on. And we're going to go straight over to Roger.
Good evening, everyone. Welcome to our second edition of our Space Oddities YouTube. I will be doing another presentation of this week's things to see in the night sky regarding the moon and the planets rising in the northern and the southern hemispheres. Right, so if I just share my little presentation and we will begin. Okay, right. Okay, so this week's updates for the moon and the planets beginning the 13th of June. Tonight is the eve of the strawberry full moon, which is tomorrow at 12:52 BST. The images that you're actually seeing on the phases are actually taken by myself. So if you would like some information on how I took these images, then perhaps we'll do that at another time. Okay, so we go to a strawberry full moon tomorrow and then go on through the rest of the week from it going from Sagittarius into Pisces on Sunday with a 68% moon on Sunday. Right, so this is roughly pretty much what the phase of the moon is for tonight. What you're actually seeing is what I call a mineral moon, which shows some of the composite materials on the surface. This is an enhanced image, not what you would actually see if you looked at it visually through a telescope or photographed it with a DSLR, unless you know how to process it. The colors that I'm showing you on here, the brown colors, that is showing you the iron minerals, and the bluey tinge colors are from the makeup of titanium, and it just shows you what sort of spread there is over the surface, just as a matter of interest. Okay, so tomorrow is one of three consecutive, what we don't really like to say, supermoon. It's just marginally larger than we would normally see. But I'm showing you an interesting scale from when it's at apogee, which is its furthest point away, to the nearest point, which is a perigee. And it's roughly 15% difference in size. So it's still not all that much bigger, but it can be up to 30% brighter even so. And it just gives you a comparison. You wouldn't really notice it unless you were viewing it just as it was coming up from above the horizon. So the dates for these moons are tomorrow, 14th of June, the 15th of July, and the 12th of August. And that will be it for 2022. Okay, right now. For the Northern Hemisphere, for planet viewing in the morning, we've got Venus coming up and Mars, Jupiter and Saturn all gradually coming further up, although Venus is going slightly further away from the other planets. And then we are getting Mercury coming up. Now, Mercury is at greatest western elongation on Thursday, where it's 23.2 degrees west of the sun. So if you want to see Mercury, this is your best opportunity in the wee hours of the morning. Okay, so as you can see, right. Now, as we have that, in the southern hemisphere, we've also got Venus, Mars, Jupiter and Saturn, although Mars, Jupiter and Saturn are far higher up in the sky than us poor unfortunates in the northern hemisphere. But as you can see, Venus is setting as you go further through the week until it completely disappears, with the moon encroaching past Saturn on the way through to the week. And that's my brief resume of what we have got for this this week's news.
Thank you very much, Roger. That's very useful indeed. And if you have any comments or you want to say anything, by the way, don't forget to use the live chat, viewers. We love to hear your comments. So do put something in the live chat just to say hello if you want to. We'd love to hear from you, just so we know we're not alone in this Celebrity Squares type the outfit that we've got here. Daz, you were going to say something.
Yeah, just a quick one. I was just as Roger was pointing out on his mineral moon, you can see the distinct difference in colors, and of course that also reflects the old surfaces from the new surfaces, if you can call them that, because the dark areas or the blue areas, which are called the mare, the seas, are all lava beds, so they're the newer surfaces, and so of course that's why the brown is the older surfaces, which still contains all the iron in that. So I just thought I'd put that in there just to add a bit of interest to it. And Keith's next, I think.
Yeah, Keith.
Yeah, just to say, I'm preparing a presentation on basalt, which is the rock that you see on the moon that makes the dark bits. So that's coming up in a couple of weeks.
Excellent.
Fantastic. And presumably there are lots of other metals there as well, are there?
Yeah. In fact, basalt, the most common minerals in basalt are feldspar and pyroxene. And pyroxene is an iron magnesium silicate, and feldspar is sodium, calcium, aluminium silicate. If that helps.
Yeah, that makes perfect sense. And do you know something? Whenever I hear the word basalt, I've got a Pavlovian response to basalt now. Whenever I hear the word basalt, I feel pain, because it was a couple of years ago that down at our local pond, I fell onto a large unyielding slab of basalt and snapped my femur. So, so I always associate the word basalt with pain.
So that's I'm going to say, it sounds like it's a form of kryptonite as far as you're concerned.
Oh, yeah, absolutely. Because it was so funny, because I was lying there shouting, because it was 10 o'clock in the morning and there's nobody around at the pond. I was shouting out, help, help. I thought I'd better shout it out in Spanish, probably better. So I was shouting out help in Spanish. Our nephew walked by, saw me laying on the ground, thought I was a tramp and moved on. And of course we live in the modern age. So I thought, what the hell am I doing? So I just got out my mobile and called an ambulance. And then the ambulance crew turned up in about 10 minutes, actually. And they said, oh, you're English? And I said, yeah, I'm English. And they said, oh, what do you think about Brexit then? So we're just having this lovely chat about Brexit, and then the police turned up, and they said the ambulance crew said, oh, he's English. Oh, what do you think about Brexit? So we were all sitting there having this lovely chat, and I said, should we go to the hospital now? Oh yeah, that's probably a good idea. So
so what's the answer, Andy?
Sorry.
So what's the answer?
Well, that's another story.
No.
But yeah, it was most surreal. And at one point, they put a foil blanket over me, trussed me up like a oven-ready turkey. And they were yabbering away between themselves about Brexit. And I was thinking, yeah, very good, but I'm getting a bit in pain now. Can we go to the hospital? So anyway, thank you so much for that, Roger. Very, very interesting as always.
I'd just like to say, if I may, that tomorrow's full moon is known as a strawberry full moon.
Yes.
Not by everyone, but we'll talk about that in a moment.
Yes.
I did want to say the elephant in the room, and I'm surprised nobody's pointed this out, is Roger has not told all of us how he moves forward in time to take pictures of the moon and then comes back to show us. This is a completely new thing Roger's brought in. How on earth did you get to next Sunday? I want to
know. They call him the
same every month.
That's good. Yeah.
He's got a little TARDIS tucked away somewhere. Right, thank you for that. Fantastic. So who should we go to next? Keith, what have you got for us this week?
Okay, I'll share my screen and whiz through a few things quickly. Actually, guys, I'm just there it is. Okay, right. Bear with me. I shall do it now. So I had to find it first. I think that's the one I want. Okay, share that. Right, and I'll start that up properly. Yeah. Sorry, bear with me, guys. I'm moving stuff around on the screen here. Right. The first thing I just wanted to talk about, and it's a very brief thing, is there's a couple of nebulae which quite a few people will be familiar with. The one on the left is the California Nebula. It's so named because of its yeah, it's a lovely picture. It's not mine, unfortunately. Wow. It's so called because it resembles California in shape. And then on the right, we have a denser part of the Orion Nebula. Now, star formation in these nebulae occurs not actually in the brightly lit areas, but in the dark bits where you've got denser conditions, a lot more material, and it gravitationally clumps together to form stars. One of the things that's certainly been noticed is that the rate of star formation in the California Nebula is considerably lower than in the broader Orion Nebula. Now, I don't just mean the bright bit that we're all familiar with, but the area surrounding it as well. And it turns out, actually, that there are two or three reasons for this. The first thing is it turns out the California Nebula is a sheet-like object. It's actually quite thin in one dimension, but you can't tell from the angle we're looking at it from Earth. The second thing is that the ages are different. The California Nebula turns out to be about half the age of the Orion Nebula. California is about 5 to 10 million years old. And finally, the density of the nebulae is different. There's more material per cubic meter in general in the Orion Nebula. None of these are terribly surprising, but it's nice to get this confirmed. And the data that helped to produce this result, of course, has come from Gaia, the orbiting observatory that measures the distances and positions and behavior of stars. Okay, moving on. Let's see if I can do that. Hang on a minute. Right. Yeah, the next one is Uranus and Neptune. Well, we know they're both ice giants and they both have a bluish color, but they don't have the same blue color. And of course, there's been much speculation as to why Uranus has a paler blue, more hazy appearance, and Neptune has a much stronger blue color and more well-defined cloud patterns. Well, it turns out that there are chemical hazes in the atmospheres of both these planets, consisting of aerosols, little droplets suspended in the atmosphere. But the difference with Neptune is that methane ice particles, snowflakes, if you like, extend into the lower haze level, the aerosol 2 layer, pick up all the droplets and carry them back down into the atmosphere, thus clearing that haze layer more efficiently than what happens in Uranus. And that is why Neptune has that brighter blue and clearer appearance. Finally, the last thing I'm going to talk about is, well, I'm going to talk about trans-Neptunian objects, some of which, of course, are in that belt called the Kuiper belt, named after Gerard Kuiper. And by the way, if anyone's wondering, it doesn't seem like Kuiper's spelt that way, but that is the way it's pronounced, according to somebody from the Netherlands who's told me a while ago. Anyway, trans-Neptunian objects, let's face it, they're small objects, they're a long way away. How the hell can you measure anything on objects that remote? And of course, they have, scientists have, and it, of course, it was the discovery of a trans-Neptunian object called Eris, which really put the cat amongst the pigeons, because it was broadly the same size and mass as Pluto, and undoubtedly led to the demotion of Pluto from planetary status to dwarf planetary status. But how do we know anything about Eris? Well, it turns out that 50 trans-Neptunian objects have got moons orbiting around them, and Eris is no exception. It has a small moon called Dysnomia, and you can see the image on the right there. It's taken with the Hubble Space Telescope. Now, if you've got a moon, it's rather useful because it enables you to calculate the mass of the system, that is the moon and Eris itself. But there's something else you can do, and as a preamble, we'll talk about that, and that is, how do you know how big Eris is? Well, the answer is you wait for it to move in front of a more distant star, and a process called occultation occurs. In other words, Eris hides the star that's behind it as it moves. And of course, if you can time the movement and you know how far away Eris is, you can work out how big it is. But they don't just use one occultation, they'll use a series of observatories in different positions on the Earth's surface to do occultations across different parts of Eris. And you can see a sort of diagram top right that shows you how Eris occulted a star in two positions as viewed by two different observatories. So we know more or less how big it is, and it's around about 2,300 kilometers in diameter. Okay, the little moon Dysnomia, well, it's harder to assess how big that is, but we know it's pretty tiny compared to Eris. A very broad estimate puts it somewhere between about 100 and 700 kilometers in size, probably more towards the lower end. But even if it was at the upper end, it would have a mass of less than 1/200th of Eris's mass. And that's important, as you're going to see. Okay, here's another picture, by the way, that shows you the occultation process. You can see how the light from the star, represented by these graphs, is blocked out as Eris passes in front of the star. By the way, you'll notice there are vertical drops in the occultation, which indicates that Eris has a solid surface which has moved across and has covered the star up. And there's no atmosphere on Eris, because if there was, the edges of the notch, if you like, in the middle of the graph would have slopes. And as you can see, they go straight down. Okay, so moving on then. Well, what can we do? Well, the great thing is, in the 17th century, Johannes Kepler came up with a very simple law, that the mass of the system is proportional to the cube of the semi-major axis of the moon's orbit divided by the square of the time the moon takes to go around Eris. So Dysnomia's semi-major axis, which, by the way, is sort of half the long dimension of the ellipse of its orbit, divided by the square of the time it takes, will give you the mass of the system. Well, more or less, we'll see in a moment, because Newton added a bit more to this formula, as you can see lower down, and that enables us to work with kilograms and seconds and all the rest of it to get an actual value. Of course, the gravitational constant, G, wasn't actually measured until some time after Newton, about 100 years later, by a chap called Henry Cavendish. That's another story. Okay, so you put the numbers in, and the mass of the Eris system, if you put all the numbers in like that, comes to 1.66 times 10 to the 22 kilograms. Now, for people who are not familiar with this type of scientific notation, that's basically 1.66 with 22 zeros after it, kilograms. So that sounds like a lot, but actually it's nothing compared to the Earth. The Earth is 100 times greater than, well, more than 100 times greater than that. Now, if you compare that mass to Pluto, which we've also done the sums with, Pluto has a mass of about 1.3 times 10 to the 22 kilograms. So we now know that the Eris system has a mass considerably larger, about 27% larger than Pluto. Now, what about Dysnomia? Well, the great thing about Dysnomia is that we can, in a sort of rhyming phrase, discount it, because its mass is so tiny, it hardly makes any difference to the overall sum. So we can make a reasonable assumption that Eris itself is pretty close to that value of 1.66 times 10 to the 22 kilograms. So it's 27% greater in mass than Pluto. But the occultation data tells us that Eris is slightly smaller than Pluto. So from that, we conclude that Eris is denser than Pluto. And that tells us what its composition is likely to be like. It's got less ice in it and more rocky material. But nonetheless, the two are pretty close in mass and pretty close in size to each other. And you can see as a result of that, the poor old Pluto got demoted. There you go. That's how it's done.
Thank you very much, Keith. That's fantastic. So I was going to say that does indicate a more rocky body than Pluto, because Pluto's got a hell of a lot of ice, hasn't it? And possibly an ocean as well.
Yeah, possibly.
And Keith, that should also tell us a bit about how and where it formed. likely formed closer in if it has a
yeah.
higher density. So its density is probably greater than what, 2 grams per cubic centimeter, something like that.
Yeah.
Yeah.
It's
so
quite
this is
possible,
something
yeah.
that formed further in and got slung out, more than likely.
It's quite a complicated story, as you rightly say, Lou, because with these trans-Neptunian objects, we have objects that are orbiting in synchronicity with Neptune's orbit itself, as you know, Pluto and all the rest of it with synchronized orbits. And then there are plenty of Kuiper belt objects which just seem to wander around pretty much with no connection in terms of how to go around the sun with Neptune. And then we've got the Centaurs, which are pretty close, similar objects, which are further in than Neptune, and there are even Trojans orbiting in Neptune's orbit. So it's quite a complicated story, and they're still trying to untangle it. And then, of course, in addition to all those things, there are these much more distant objects, which are the ones that are being used to speculate the possibility of another planet out there, a big one.
And of course, we should mention that NASA are going to do some grievous bodily harm to dysnomia in the not too distant future with the DART mission, because what they're going to do is to slam a small spacecraft into it to see whether they can. Is it dysnomia or is it? No. I think, no, it's dysnomia. Yeah, it's definitely dysnomia. To see whether they can deflect its trajectory, even by a little, because this will help in the future if Earth is ever threatened by an asteroid, whether we can actually deflect them by slamming basically projectiles into them. It'll be quite interesting to see the result of that. This all, of course, depends on us having sufficient warning that the asteroid is coming. And of course, the most dangerous asteroids are the ones that approach the Earth from the direction of the sun and are often invisible until just a few hours before they pass by the Earth. So,
yeah, that's right.
Yeah.
Andy, do we know if the DART mission has their official soundtrack yet, and which groups got chosen?
I don't actually know, Kareem. Would you like to suggest any?
Well, I'm thinking Aerosmith. You know, they did their due diligence in the Hollywood movie. Maybe they should be up there.
I don't know. Daz, you were going to say something.
Yeah, just going back to Keith's story as regards the Orion Nebula. Of course, if you zoom in towards the center, you've got the quadrangle, the 4 stars that are burning brightly in there. But if you go off to have a closer look and you talk about star forming, if you've got something like the Hubble and you zoom in, you can actually see planetary disks forming around these new stars and all the dust and that around them. And it's just one of those things that you just see it and you think, that's a star, and that one day that's going to be a solar system. It's going to have its own planets and everything.
Yeah,
just absolutely amazing.
That's right.
And the amazing thing about that is that, of course, it was predicted that solar system formed this way by Henri Laplace back in the 18th century. Turns out he was right.
Yeah, and one of those planetary disks is edge onto us, and it looks absolutely stunning. And you think those are solar systems being formed more or less right now. So there we are. Fantastic stuff. Thank you. Now, viewers, we know that you love going out taking astronomical photographs. We know that because it must be true, because you're interested in astronomy, and everybody in astronomy at some point has the urge to get out with a camera and capture what they see in the glories of the night sky. So we've got a new feature for the program, which is the viewers gallery. And we've had a few submissions this week. And Rachel, do you want to tell us about those?
Yeah. I will just load up the screen and hopefully it will work. This is always the most awkward part where you just don't know what's going to happen.
Exactly.
Okay. Can you see my screen?
Yes, we can.
Yeah.
Awesome. So thank you for everybody to sending them in. We've had quite a few, but we've got a small selection tonight and we'll see how we go from there. So kicking us off, we've got an entry of the Cygnus Wall. This is by Martin Bracken, who I have seen in the chats today. So thank you, Martin. There's some techie details on there if you want to just have a quick look. But then we're going to dive straight into the picture, which is a lovely,
wow.
lovely image.
Very nice.
Yeah, I really love the richness
Phenomenal.
of the blues in
Lovely.
this one as well.
Keith's holding up a 10. That's a definite 10. Wow.
Yeah, so this is obviously part of the Cygnus region, and obviously due to its field of view, when you crop out, it resembles the shape of the continent North America, which is why it's larger, namely as the North American Nebula. And someone can correct me if I'm wrong, because this is your techie side, but I believe it's supposed to be glowing due to, what is it, the ionization of interstellar gas from the radiation of hot young stars, I believe. People are nodding at me. Did I pass stars?
Yeah.
And it's about 1,700 light years away and about 100 light years across. But no, it's a really lovely image, Martin. So thank you for sending that one in. We're going to break it up now and keep it nice and simple. We've got Ursa Major Framed by the Clouds by Chris Jones, who again I've also seen in the chat. So this is just simply showing what you can do on a smartphone. So I really liked this entry because we're so used to seeing so many images taken with really high-end gear, but actually I think there's a saying that says the best camera is the one you have on you, and this is just a really lovely wide field of.
That's lovely.
Obviously you see the
carefully,
cloud straight away, but you can actually start to pick out the rest of the constellation just peeping.
You can even see the double star there in the tail. You can see Alcor and Mizar.
Yeah, you got
Yeah, you can see Alcor and Mizar. Yeah.
Alcor and Mizar are there, yeah. Well done, Chris. Great.
It's handheld. It's a fantastic photo.
Yeah, because I know mine always end up I get star trails, even though it says stand still, and I really try. I never get an image as crisp as that off a phone, so it's really, really impressive. And to finish, because I tried to keep it quite short and sweet this week, we've got another entry of the North American Nebula by Clem Fisher, which has got a total integration time of 4 hours, 5 minutes. Again, you've got lots of techie options if you choose to take them in, or you can pause them and go back and look later. I did have to rotate this one, Clem, because it wouldn't fit portrait, but it's well, yeah, I looked at this for a long time. I think it's beautiful.
It is lovely.
I love the color.
Just the richness of the color, and I just always think the Cygnus wall looks like some sort of bird, sort of soaring aerial view down over an ocean. I just think it's just a really lovely image.
Yeah.
Are those brush strokes? You sure this wasn't painted? It's really pretty.
But I love how there's two identical sort of entries this week, but they both look so different. The composition and just the way you process it, and your flair just changes everything, doesn't it? Because there's two gorgeous images, but look completely different.
That's beautiful. That is.
Yeah,
there's a real 3D effect to that. If you look top right, that really does look 3D, doesn't it? It's amazing. Excellent.
Absolutely beautiful. And that's sort of where I called it this week. I'm hoping more people will get on board. I'll post some details in the chat if you want to submit entries for next week's show. We can get those in, and obviously the panel are welcome to put some in if you choose to be daring enough.
Well, yes, but viewers, get those photos into us. We'd love to hear them. How can they actually send them to us, Rachel?
I'll put the details in the chat. I'll send the email detail and what you need to do in the chat. And
I will add that to the description in this video later. So thank you very much indeed. Slight correction. I am of course a total fool. I was referring to the DART mission going to Dysnomia, but of course it's going to Dimorphos, not Dysnomia. So I always get my dyes mixed up, so I inherit that from my mother, and so there we are. So yes, DART is going to the near Earth object Dimorphos, not Dysnomia, companion to Eris. Anyway, moving on, just a couple of things that have been in the news. Hot off the press is the news that the FAA, the Federal Aviation Authority in the United States, Federal Aviation Administration, I should say, in the United States, have given permission to SpaceX to carry on operations at Boca Chica in Texas. They've been conducting a lengthy environmental assessment because there are protected species and all sorts of other stuff around the area. The report that they've produced has been delayed many times, but today finally was the release date. They've asked SpaceX to make 75 environmental changes to the way they're doing things at the moment, including hiring a biologist to monitor bird life and general wetland population, because it is a big wetlands area there with some rare species. There's a species of plover there that's quite rare. And people have been concerned that SpaceX were having an effect on its breeding. And the bottom line is 75 changes. SpaceX, I think, have already agreed to most of them. So SpaceX can continue launching from Boca Chica. And before too long, sometime this summer, we're hopefully going to see the first attempt to get into orbit with the Starship atop the Falcon Super Heavy booster. The second thing was commiserations to Astra for losing 2 NASA satellites last night. The 2 NASA satellites were part of a small constellation of 6 satellites that are going to monitor the formation of hurricanes and learn a lot more about they were going to learn a lot more about the formation of hurricanes. Let's hope NASA have got 2 spares. It was a perfect launch, a few delays, but it was a perfect launch. But the second stage engine shut down too early for the spacecraft to get into orbit. It shut down about a minute too early, and it's assumed to have re-entered the atmosphere and burnt up somewhere off the coast of Africa, they think. So that was a bit of a shame. So bad luck, Astra. I'm sure they'll bounce back from that. Now, before we go further, let's do my little bit for the week. And I've got 2 things for you this week. Just let me set this up, and let me share my screen. Okay. Okay, so what do I got for you this week? Japanese scientists have been analyzing the sample from the asteroid Ryugu, which was visited by their Hayabusa 2 spacecraft in 2020. And the samples that they took were returned to the Earth and parachuted down into a desert and were collected. And they have proved to be exceptionally interesting. So here's an artist's impression, courtesy of the European Space Agency, of the spacecraft just descending and putting a probe into the asteroid Ryugu and collecting some samples. Now, this asteroid is essentially a junk pile. It's made up of very, very loose material, as you can see in this image. And it's a type of material that we normally associate with those famous meteors known as carbonaceous chondrites. So there's a lot of carbon there. And it's caused a few surprises because it was assumed that asteroid Ryugu consists of this really primordial material from the birth of the solar system. This is one of the samples that was returned to the Earth. As you can see, it's very dark, lots of carbon there, and very loose material. And they've analyzed this material. And first thing to say is that it does actually predate the formation of the solar system. Perhaps it even predates the sun. So this is exceptionally pristine, ancient material from even before the birth of the solar system. Its age was quite a surprise. We knew it was old, but not quite that old. Secondly, it does contain multiple organic compounds. And before anybody gets excited about the use of the word organic, no, it doesn't mean life. Organic in chemistry simply means any chemical processes involving carbon. So that's what organic means. So, but there are a few interesting carbon compounds in there. But perhaps the biggest surprise is that at one point the material had been soaked in water, which is quite a strange thing because we don't know the history of water in the solar system. We don't know where most of Earth's water came from. You'd think something like the Earth would have that worked out by now. But where Earth's oceans came from is still a bit of a mystery. Lots of suggestions as to where it came from comets and you know, planetoids and asteroids and that sort of thing. There was a suggestion recently that it had actually come from the sun itself. the sun's solar wind reacting with the atmosphere of the early Earth to produce water. That's another suggestion, but we don't really know. But we know that obviously water's had a major effect on the evolution of the planet and other bodies in the solar system. So this was quite interesting to find out that that material had at some point in its history been soaked in water. So we will also have the samples from asteroid Bennu, which NASA visited, and they will be coming back to Earth next year. And it'll be really interesting to compare the two asteroids because they're both thought to be primordial material. Bennu, in fact, turned out to be an even looser pile of rubble than Ryugu, because when they went to take a sample, they actually ended up with a lot more than they bargained for, which caused a few problems stowing it on the spacecraft for return to Earth. But anyway, that's to look forward to next year, the samples from Bennu. Second thing I'd like to talk to you about tonight is a series I'd like to do called Weird Wonders, those weird things in the universe that we don't really understand, if at all. So if you've got any suggestions, viewers, for weird wonders that you'd like to know a bit more about, whatever they are, put them in the comments, and I'll do my best to talk to you about them. So, you know, if there's something weird in the universe that you don't understand or you'd like to know more about, tell me about it. So today it's neutron stars. Now, neutron stars are, after black holes, possibly the weirdest things in the universe. They really are the weirdest things, and as well as black holes, exceptionally dangerous. So first of all, if you go into under the night sky in winter, you'll see the famous constellation of Orion, and its left shoulder is made up of the star Betelgeuse, which was in the news last year and the year before for undergoing this strange period of dimming. However, that's for another day. Betelgeuse is a red supergiant star. It's one of the few stars that we can actually take a direct image of its surface, because although it's over 600 light years away, it's big. And if you would compare the sun to this image of Betelgeuse, it would be about the size of a pinhead. It's a massive star, a big bloated star. And this is a red supergiant that is going to explode, or almost certainly going to explode in a supernova explosion sometime within the next 100,000 years. So I don't think we're going to see it somehow. However, what happens to these massive stars after they explode in a supernova is, there's just a comparison so you can see Betelgeuse compared to other stars, Antares, Rigel, Aldebaran, and the sun right at the bottom. So you can see how big Betelgeuse actually is. And when it does explode, what will happen is that it will throw off most of its atmosphere in a huge explosion, which we call a supernova explosion. And what it will leave behind is the core of the star. Now, gravity will then get to work and compress the core of a star, which may be hundreds of thousands of miles across, or even larger. And what will then happen is gravity will compress it so much, it will compress it down to something we call a neutron star. Now, just to teach you some basic things about the neutron stars, they are, just a few kilometers across. You can see here compared to the size of Manhattan. They range from about 1.1 to 2.3 solar masses, although we have actually discovered recently, or astronomers have discovered recently, some ones that don't quite fit in that bracket. A teaspoonful of neutron star material would weigh, are you ready for this? A teaspoonful of neutron star material would weigh about 4 billion tons. So these are exceptionally dense objects that have had everything except the neutrons squeezed out, basically. And they have such, because they have the density, they have an amazing gravitational field. An average neutron star has a gravitational field about 1,000 billion times stronger than the Earth's. And if you were to drop a ball onto the surface of an average 12-kilometer neutron star from a height of 1 meter, by the time that ball hits the neutron star, it will be traveling at 1.4 million meters per second. So that is quite a thought. What's inside a neutron star? We'll have a look in a moment. Just to very briefly go through the different types. First of all, we have pulsars, which are the most accurate clocks in the universe. These are rapidly spinning neutron stars that emit jets of or beams of radio waves and or gamma rays that we can detect from the Earth, and they spin like a lighthouse, like that. And if the Earth happens to be in the way of one of those beams, we see it as a flash of radio light. But this one here is quite sedate. That one is the Vela pulsar, and that rotates about 11 times a second. And hence you can hear the pulses at a much accelerated rate. Inside a neutron star, we don't really know, basically. There's a thin atmosphere made up of hydrogen, helium, and carbon, it's thought. An outer crust, which may only be a few millimeters thick, of ions and electrons. Then you have an inner crust, which is made up of superfluid, and then we have an outer core and an inner core, but we don't really know what goes on there. There you are. Then I just thought I'd give you a brief introduction to pulsars. And as I said, if there's anything that you want to know that's weird from my Weird Wonders series, put them in the comments, and if I can, I will do something about it and tell you all about it. So there you go. Right, where do we go to next? Bernard, how are you over there, Bernard?
Oh, I'm doing fine. Thank you so much. Thank you so much. I actually had a question for you in your previous presentation. So about the pulsars.
Yes.
Where is the closest pulsar to us at the moment?
Oh, that's a good question.
Am I putting you on the spot? Is it like, are there pulsars in our galaxy?
Oh, God, yes. I mean, the famous one is the one in the Crab Nebula.
Right.
which was one of the first ones discovered. The Vela pulsar, which you heard, that was the first one ever discovered.
Right.
I'm not sure the distance to the Vela pulsar, but it's not that far away. And yes, I mean there are many of them that we know of. We know of hundreds of them in our galaxy alone, so they're extremely common. But yes, Michael, have you got a figure there?
Yeah, I just had a quick look on the internet for that. According to Neutron Star Physics blogspot.com, they suggest it is PSR J0108-1431, and it's about 280 light years away.
There you are.
I thought it was, but I wasn't sure.
And it's in the constellation of Cetus.
Astronomically, just around the corner, then.
Yeah, exactly. Are we going to be able to observe pulsars with the JWST? Is there any reason to do so?
Well, I don't think there's much of an infrared signature with pulsars.
No, exactly.
No, you're right.
The closest one, the one that was referred to, that one is very low luminosity, but it's not infrared, right? It's just very low luminosity, but it's very high energy photons.
So these are mainly visible in radio and gamma.
Oh, you're right. Yeah, of course. You did say it earlier.
Yeah. Steve's got a question.
Steve's got a question. You're muted, Steve.
Yeah, come on.
Don't worry.
Apologies. I'm just going to throw in that the first exoplanet was actually discovered around a pulsar, as it happens.
Yes, that's true.
That's correct. Yeah.
The Crab Nebula is the remnants. The pulsar at the center of the Crab Nebula is the remnants of a supernova that was observed by the Chinese in 1054. I think.
Correct.
It was.
That's right.
And the Chaco Canyon.
It was observed. First discovered by Dame Jocelyn Burnell, if I remember right.
Yes, indeed.
That was the very first one discovered. As she called it, a bit of scruff on a trace from a. It was a large radio telescope that they built themselves in a Cambridgeshire field, and she had to spend her nights, and it was done with a pen trace. And she had to go in. One of her jobs as an undergraduate was to go and collect the traces and then study them for any sort of strange signals. And she noticed this scruff a couple of times, but it wasn't really sure of it. And it wasn't until they actually speeded up the trace that they were able to see that actually there was a definite pulse in it, because And of course, they called it LGM for Little Green Men,
Yeah,
and it caused
indeed.
a lot of consternation because they thought it was intelligent life trying to get in touch with us.
Yeah.
But
Well, perhaps
think
next
she-
week. Sorry, go
Sorry, I
on.
was going
Mary.
to say she deeply regretted writing that, by the way.
yeah,
Yeah.
but it caused a lot of trouble, didn't it? Because the army and everyone else got involved because they thought they were trying to be thing, and she was sort of like sidelined as well. But that's another story for another day.
Well, similarly, the guy who wrote "Wow" next to the famous "Wow" signal, our best candidate yet for an extraterrestrial signal from aliens, apparently he regrets writing that. He wishes he'd written something a little more scientific, like "That's dashed interesting" or something like that.
Golly,
golly, yes. But he wrote "Wow." Yes, Keith.
I could say the history of the awarding of the Nobel Prize has often been controversial. And of course, it was Jocelyn Bell Burnell's PhD supervisor, Anthony Hewish, who got the Nobel Prize for the work on pulsars. It seemed grossly unfair. But I think history has won out because Jocelyn Bell Burnell is well known now, and Anthony Hewish, who he, I mean, most people don't know who he is.
She's had a glorious career in radio astronomy.
The only one who didn't actually see any controversy in it was Jocelyn herself. She's always said that it should go to her sort of like her teacher, a mentor. She was just an undergraduate, and it's an amazing story.
But if you think about it, it would have been unprecedented to award a Nobel to a graduate student, because she was only a graduate student at the time, and that had never been done before. So, coupled with the sexual politics of the era, she just missed out there. Okay, moving on. Michael, tell us what you've got going on.
Okay, thank you very much, Andy. Wait me a second. Okay, so good evening, everybody. I'd like to introduce you to Go Space Watch. We provide online lecture meetings with talks on astronomy and spaceflight. And our next meeting is this Wednesday, the 15th of June at 7:30 p.m. at BST. And for our international viewers, that is UTC +1. If anyone likes not know that. Our meeting, the lecture, is To the Mountains of the Moon, Remembering the Flight of Apollo 16. 50 years ago, in April 1972, Apollo 16 almost didn't land on the moon. Against many odds and a fair share of misfortune, John Young, Charlie Duke, and Ken Mattingly flew one of the most successful missions to our nearest celestial neighbour. The speaker is a good friend of mine, Ben Evans, and he's been writing books for several years now. He's now written 11 books for the Springer Praxis company, and also writes for americaspace.com. Anyone interested in joining our meeting on Wednesday, the cost is just £3, and I will put the link in the chat on the YouTube channel to go to.
Great.
Thanks very much, Andy.
Thank you very much. Bernard, sorry, I cut you off mid-flow there. Was there something you had to tell us about this week?
No, well, just the fact, I don't know if you've mentioned this before, but as we all know, Boeing has been having some difficulties with Starliner. And it's worth mentioning that Boeing has decided to move its headquarters again. I don't know if you recall, over a decade ago, they decided to move from Seattle, their home base, to Chicago. And recently it was announced that they were going to move from Chicago to near Washington.
Really?
And so that's always very interesting to see how these big conglomerate organizations move, because obviously they're trying to go probably closer to the money. And I think it's something worth following and worth watching as we go forward.
Yeah, definitely. They've just I don't know whether you know this, but when Donald Trump was president, he decided that he would repaint Air Force One, and got Boeing into a fixed price contract to do the job. And now that that fixed price contract has gone completely bananas. It's gone completely wrong, and Boeing don't think they'll be able to do it under the agreed price, and it's all a disaster. So, you know, Boeing have really, since they merged with McDonnell Douglas, they've been on a real downward spiral. So anyway, let's see what happens. Right, where do we go from here? I want to get to Lou, but before we do that, we're going to go to Lou by way of Mary, because Mary has produced the most stunning piece of artwork this week, for which I think Mary deserves a round of applause. Mary, tell us about this wonderful artwork that you've done.
You're muted.
Many years ago, I was at Astrofest, and one of the scientists from NASA showed a photograph of this picture taken by the Lunar Reconnaissance Orbiter. And it's a sun rising over the central peak of crater Tycho. And those of you that know me know that I love to do astronomy sketching at the eyepiece, but also from photos, because I love dark shadows on the moon so much. This has been high on my hit list to create some artwork of, and I finally finished it the other day. So this is the sketch, and I thought it'd be useful to, just because people keep telling me it looks like a photo, I thought it'd be really useful to very quickly whiz through how I approach something like this. Because if you can't sit at a telescope eyepiece, or you don't have a telescope, you can still do sketching from photographs. So the way that I begin is to just very carefully mark out, just in light terms really, where the shadows are. Then I very loosely, kind of with the white pastels, this is on black paper with white and black pastel pencils. And then once I'd marked out the outline, when you're doing a complex region like this, always think about where is getting the most sunlight, where is getting the least sunlight, and also the way that you blend it. So sometimes the slopes look like they need to be blended downwards, and then you can go in layers and just keep adding highlights and shadows. So once I'd done that central bit, I then kind of added to some of the more foreground hummocky hills that were there, then added some of the other bits on this right-hand side. So these are just foam pictures.
Can you actually show us the image?
Oh, have I not shared my screen?
No.
I thought I'd shared my screen.
Oh, no.
Okay, so I've been talking to my presentation to myself. Sorry about that.
That's okay. There.
Okay, so yeah, this is this is the artwork. So I'll quickly whiz back through those steps. So yeah, I mark out the shadows, look at the highlights, and I mark out where the really bright bits, where the really pale bits are, how to blend to. I don't try to necessarily go for photorealism. What I try to do is mimic a texture with my pencils that looks like what I'm seeing on the picture. So if that involves blending downwards and adding a few black squiggles, that's what I do. A few white squiggles where necessary. That if you look at any one bit of my sketches, they're not that detailed really, but just adding in that texture and making sure the bright sunlight's hitting the same regions, and then the same over here. And then I wanted to mark out the shadows again and then add some texture for the background. Normally my backgrounds are blended a lot, so they're nice and smooth, but the background on this photo was very chunky and gravelly. So I actually decided to go over without blending and then add in some more of those features. And once I'd kind of done all of that, I then colored in all of these shadows and blend to try to get rid of the pencil marks. What I then did is kind of went around the outside again and muted that down a little bit, because in the photograph the big peak at the middle is the bit that really stands out, and by the time I'd messed around doing all of this other stuff over a 2-week period, that had dulled down a bit. So I just went over, marked out the darker bits again, and just went over some of those highlights. So if you break it into chunks like that, you can draw absolutely anything. And I'm really pleased with how this turned out, because it's something I'd wanted to draw forever. And so I really just urge you, I mean, I'll show you the original picture here just so you can see the not compressed version. But if you can just find any photograph taken by an orbiter, whether it be of a nebula or of the moon, just try to draw it, because you're not going to get a better high-res picture than that to work with.
I think it's wonderful. Actually, I think it is actually a photograph. I don't think it's a pastel sketch at all. I think you're having us on. No, well, superb work.
Fantastic,
Absolutely
yeah,
superb. Yeah,
fantastic.
round of applause for her, because I
Wonderful.
think
Great.
that's a stunning image.
Amazing.
Okay, right. Moving on. We come to Lou. What have you got for us this week, Lou?
I'm gobsmacked that I was sure that was an LRO image, Mary. And
Yeah.
Here's what I used for my model, and here's that was stunning.
Yeah.
I got a couple of things. We'll see what we have time for, but I think I want to kind of move into a place where it's a little less comfortable. Let's see if I can share my screen here. And there we go. See anything familiar there? Screen.
Nope.
No, where is that exactly?
Silly boy. So we all grow up and go to school, and we learn that there are, well, depending upon when we went to school, 8 or 9 planets. And we're taught the order of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and whatever. And that's the way it is. And so that's very nice and comforting, and it's always been that way, and that's the way it will always be. But there are a few problems with this model. And these problems come from better observations, better computers and computer models. And this model doesn't explain a couple of things. The first is, if we look in the upper left there, why don't we have any hot Jupiters in our solar system? When we look out at other exoplanets, we now know of over 5,000 exoplanets. We see lots of hot Jupiters. Some of that's a selection effect, right? It's easier to, if you're using a transit method, it's easier to spot a large planet near its sun, but we see a lot of them. Why don't we have one? Another thing that this nebular model of solar system evolution doesn't explain is why Mars is so small. When we run computer models, Mars should be bigger. It should be bigger, and that's a question that remained unanswered for quite a while. We also know that there's a asteroid belt between Jupiter and Mars. Originally, that was thought to be a planet that broke up. Now the prevailing theory is that it's just leftover material that never quite formed. Why didn't it form? And the other question is, and we talked about this a little bit already, didn't we? Where did the water come?
Yeah.
For Earth? I think largely it's believed that the Earth formed dry, water couldn't condense in the inner solar system. There are other competing ideas, but I think that's the breadth of scientific understanding. So where'd the water come from? Well, it turns out that if you take our new computer systems that are able to do massive parallel processing and cloud computing and data analytics, and you throw all that at this problem, you come up with something that looks like this. That the solar system did not form in this nice order originally, but the solar system has been on the move. And what we think happened, and this is called the grand tack model of solar system evolution, that Jupiter formed not out at 5 AU, but probably around 3.5 AU, and started migrating inwards, losing angular momentum, running into gas and other things left over that were still floating around from solar system accretion. And as it started moving inward, it disrupted material that could have been used to create Mars. So Mars didn't have quite as much stuff to form from. It also kind of kept things a little unsteady in the gap between what is now Jupiter and Mars, which made it difficult for things to form in that region, and also slung a lot of material out on its way. And if that's all there was to the problem, we would have a hot Jupiter right now, a Jupiter that was orbiting perhaps within what is now the orbit of Mercury. But Saturn formed, and Saturn started migrating inward just like Jupiter, and kept Jupiter from migrating any further than about a little over 1.5 AU, about 1.5 AU. In that process, Jupiter and Saturn turned around, started migrating outward, and Uranus and Neptune, which there's not enough material to form Uranus and Neptune way out at 10 and 20 and 30 AU, they formed closer in, and we can see that that makes some sense if you look at their relative densities, that they're denser than their Jupiter and Saturn counterparts. So as Jupiter and Saturn started migrating out again, they swung Uranus and Neptune, which had formed closer in, out into what is their current orbits. So this is called the Grand Tech model of solar system development. It works really well in developing in computer models. It also explains why we have water on Earth, or rather, it's consistent with an explanation for why we have so much water on Earth, because when we run these computer models and we take this into effect, we find out that enough of cometary material probably hit the Earth to form pretty much exactly the amount of water in our oceans on Earth. So the solar system has not been this way forever, and it won't be this way. It will continue to change, and of course, the ultimate change will be when our sun sloughs off a fair amount of material, encompasses Mercury and Venus, maybe Earth. The sun will weigh less because it's blown out a lot of its material. The planets will move outward, and the right place will be to live on shorefront property will be Titan. So I just wanted to present this to you, that things are not always as they seem. Yes, Daz.
Yeah, just as you were saying about when Jupiter moved in towards the sun, and it took up all this material that would have made Mars. A survey's just come out as regards Jupiter, and they're saying that its metallicity is higher than what it should be, and it's 9% rock and metal. And they have now decided that that was, like the process you just said, it was in its early days, it was swallowing up planetesimals, not small pebbles or anything like that, but actual small planet forming planets, to be able to have such a high metallicity that they get reading in its atmosphere now.
Yes, you know, it may be when we talk about going into the outer reaches of the universe and looking for other planets, it may be that one of the conditions for life, we need heat, we need water, and so on. One of the conditions might be a Jupiter-sized planet, because Jupiter absorbed a lot of the small objects that could have hit Earth, and either broken it apart or destroyed whatever life had developed. And it may be that a Jupiter-sized planet kind of keeps you safe in the inner solar system. Yeah. Steve.
Yes, I was just going to throw in that I think I've heard of a variation on the Grand Tech model called the Nice model, which I think indicates that maybe originally Neptune was inside the orbit of Uranus originally, and when the Jupiter and Saturn moved out to their current positions, Neptune moved out beyond Uranus to where it is now.
Yes, that's right. The Nice model is called that because it was developed in Nice, France, or first promoted in Nice, France. And it deals mostly with the outer solar system, not so much the inner solar system. But right, and you can see that if you plot the densities of Uranus and Neptune, you can see that, let's see, it would be Neptune has a higher density than Uranus. and that would be consistent with how it formed if through the Nice model.
Because doesn't some of the Juno data indicate very much that Jupiter did not form where it currently is because of its composition? These ideas have been around for ages, but that's really interesting, and this does explain why we haven't got any putting the sampling effect aside. That's why we haven't got any hot Jupiters. Which is quite stunning. Right. Okay then. Well, ladies and gentlemen, I guess that's it. Viewers, I think that's about it for this week. Please, panel, tell me I haven't forgotten anybody. Anybody I've forgotten that wanted to present something?
No, it's fine.
Just me, but I don't mind
Kareem,
waiting.
I think you had something, didn't you?
It's okay. I don't mind waiting till next week. It's all good.
Just one thing, Andy, is that today on the 13th of June, we had the 4th data dump of the Gaia mission,
the Gaia data,
which was mentioned earlier on. And in this dump, they're also releasing the spectropic analysis. So now they'll be able to measure the fingerprints of the stars and be able to, with the previous data and running things backwards and forwards where they're moving and things like that, they hope to find out which stars were related, because as we know, stars don't usually form on their own. They form in a clump, in an open cluster, and then they slowly spread apart. And a good example of that is the Pleiades and the Hyades, which are next to each other in the sky. The Pleiades is a nice little group of very young blue stars moving around. They'll eventually pull apart, and the result will be like the Hyades, which is in Taurus, where now it's got to the stage the stars are so far apart that it may actually not be considered a open cluster anymore. I just thought I'd like to put that in there. So.
Thank you, Das.
Can I just add that let's not forget that Gaia mission is one of the most productive missions ever sent into space, there are more scientific papers produced with Gaia data than any other instrument we've launched, even more than Hubble. So having the 4th data dump now is just phenomenal.
It's running till 2027, and I think there's another planned 3 dumps, I think, of data. So we're going to be awash with it. So citizen science, here we come.
Absolutely.
Definitely.
Andy, can I take just 2 minutes to follow up on Roger's comment about the strawberry moon?
Sure, go on.
I think it would be a good thing to just point out. It is here in Canada Indigenous History Month, so I wanted to make sure to mention that the full moon isn't the strawberry moon for everyone. It is for us here in Quebec and for the Ojibwe of the Great Lakes, and by most of the North American settlers. We call it the strawberry moon because it's strawberry season, and we've seen some luscious strawberries coming to the markets this past weekend. But for other nations, First Nations here in North America, for the Cree, it's based on the waterfowls coming and actually laying their eggs, and you want to protect them and make sure that they are able to be sustained. And for the Mohawk and the Cherokee, they talk about the fact that you have crops that aren't ready to be picked. You don't want to pick the fruit, you don't want to pick the corn until it's actually ready to sustain your tribe forever and ever. But let's not be North Hemisphere centric. Let's keep in mind that it is winter solstice coming up in Southern Hemisphere. So in Australia, they actually refer to the June moon as the cold moon or the long nights moon, because the moon rises higher in the sky for them. Remember, back in January, we had our spirit moon, our chief moon, because the moon was so high during December and January during the winter solstice for us here in the Northern Hemisphere. Well, the Southern Hemisphere gets that same behavior now. So I love doing the two-eyed seeing and talking about kind of the connection between where we see the moon, how the moon associates with nature, and how it's revered with all of these Aboriginal and First Nations tribes. And so with it being our Canadian National Indigenous History Month, I wanted to take a few moments to just mention the other moons. But I did tell Roger I'll have some strawberries in his name tonight. So
thank you so much, Kareem. Interesting stuff as always. Just another thing on the Gaia data. Gaia has now mapped with exquisite precision 2 billion stars in our Milky Way galaxy. And looking at the release of the data today, it turns out that they have detected a lot more starquakes than was expected. These are like earthquakes on the surface of a star, hence the name starquakes. And apparently the guy has turned up a lot more than there is currently an explanation for. So that's quite interesting, one for the future. Okay, viewers, thank you so much for joining us. It really is good to have you with us, and we've enjoyed reading your comments, and thank you so much. And don't forget, if there's anything you would like to see us cover in particular, whatever subject in anything relating to the universe, if you'd love to know more about a particular thing, or you'd like us to concentrate more on one thing more than another, do put that in the comments as well. We want this to be as much for you as it is for us. So, give us some feedback. Tell us what we're doing right. Tell us what we're doing wrong, because we can only improve if we have feedback from good people like yourself. We will, of course, be back next week, same bat time, same bat channel. But until then, we'd like to wish you all a fantastic week. And we'll be back here next Monday at the same time with yet more stories from our wonderful universe. Until then, take care of yourselves and goodbye.
Take care, everyone.
Thank
you.
you.
Bye.
Bye. Bye.